So when you look at this, the first thing that you should notice is the denominator here, the plus sign. That is going to be your arctangent function. And the rule for arctangent is that if you have 1 over a, or we actually say it's du, if you have du over a squared plus u squared, that is going to be equal to the integral of 1, that integral is going to be equal to 1 over a, and then arctangent u over a plus c. Okay, so what you have to do to apply this rule is you have to match up the a, the u, and the du. So if you look at the current integral where you have 1 over the square root 3 to square root 3, and then you have dx over 1 plus x squared, you'll notice that your a is equal to 1, your u is equal to x, and your du is equal to dx. So you have exactly a one-to-one relationship there, and you can just plug in these values of a, u into the formula. So you will have that this is equal to 1 over 1 arctan, our u is equal to x over a, which is 1. And you'll notice we will not put the plus c here because we do have bounds. We have the 1 over the square root of 3 to the square root of 3. Okay, so at that point you've done the integral part, but then you have to do the definite integral part by plugging in the upper bound minus the lower bound. So when you do that, you will have just arctangent of the upper bound square root of 3 minus, and then arctangent of the lower bound 1 over the square root of 3. Now, remember that with these arc trig functions, what you're trying to do is to evaluate this, you're trying to find an angle tangent theta is equal to the square root of 3. That's what you're trying to find. And in order for the arc trig function to exist, you can only look in the right-hand side, not including pi over 2. So you have to be somewhere between negative pi over 2 and pi over 2. Okay? Now, here's where you're going to use the material that you learned back in trig, where you convert your tangent into sine theta over cosine theta. And what you'll probably want to do is you'll remember that those trig functions were over 2 and then over 2, so the 2's would cancel out. So square root of 3 is the same as square root of 3 over 2 over 1/2. And so you're asking yourself what angle has a y-coordinate of square root of 3 over 2, which would be the angle of pi over 3. So this is going to be where you have a sine of square root of 3 over 2 and a x value or a cosine value of 1/2. So you'll have pi over 3 minus, and then you have to do the same thing for this arctangent of 1 over square root of 3. And probably the easiest way to do this is that if you are trying to find an angle tangent theta that's equal to 1 over square root of 3, that is just going to be, instead of a 60-degree angle, that is going to be your 30-degree angle. That's going to be your pi over 6 angle. So you'll have minus pi over 6. And you can see that quickly if you think about this, again, as sine theta over cosine theta, where your sine is 1 over 2, and then your cosine would be the square root of 3 over 2. And that would reference the pi over 6 angle. Okay? Now, this is our upper bound minus our lower bound, and then we have to get our little common denominator, so multiply this by 2 over 2. So you get 2 pi over 6 minus pi over 6, which just gives you pi over 6 as your final answer.